Hello friends, so today we're going to discuss this question from Leetcode challenge problem named construct binary search tree from Preorder Traversal. So we have to return the root node of a binary search tree that matches the given preorder traversal. So there are three types of traversal in a tree: pre-order, in-order and post-order. So in pre-order traversal we first look at we first print the or look at the root value, then we move to the left and then to the right. So this is the input which represents the pre-order traversal of a BST, and we have to output this tree, the root of this tree. So let's do a pre-order traversal on this tree. So first we print 8, then we move left, we print 5, then we move left, we print 1, then there is no more left, so we move back, and then we move right, so it's 7, then we move back, then we move right, it's 10, then move left, it's 12. So that's the pre-order traversal. So what we can do is, I've drawn the same tree here. So what we can do here is, we can move iteratively over this tree and we make a stack to store what are the values which are greater than any number. So let's see with this example. We are first at the root node or the first value of the input. The first value is always the root node value. So this is the first value of the root node 8. So we push it in the stack. Remember, we're pushing it the node, not the value itself. We are pushing the initial node 8 in the stack. Then we move to the next value, which is 5. Now 5 is smaller than 8, the top value. So we again push 5 in the stack, the root node, and we make it to the left of the top value. Now we move to the 1. 1 is also smaller than the top value. So we insert 1 to the left of the top value in the stack, and we move again to the left. So now the top value is 1. Okay. Now we have 7. So because 7 is not smaller than 1, we have to, what we have to do is, we have to keep track of the top value and we have to pop it out till we get a number, whether the stack become empty or we get a number which is greater than the top value or this value. So 7 is greater than 1, so we have to pop it out, and we make a pointer which stores the address of this top node. So now it's at 1, so it means 1 is at the previous node, and we pop it out. So if we pop it out, our stack becomes this. Then we compare this 7 with 5, the top value. Is 7 again greater than 5? Yes. So we pop it out again, and now our previous become 5. Now as 7 is again greater than 8, no, 7 is not greater than 8. So it means 7 is the right child of the previous one, as you can see. Previous one, the right child of just previous one is 7. So now we make the right child of the previous node equal to 7, and we push 7 in the stack. Okay. Now we come to 10. Is 10 greater than 7? Yes. So pop it out. And previous is equal to 7. Is 10 greater than 8? Yes. So also pop this out. And the previous now become 8. So previous now become 8, and because there is no item left in the stack right now, 10 become the right of this, the previous one, and we insert 10 in the stack. And that's the simple logic. Then we see 12. 12 is greater than 10, so we pop this out. And now our previous become 10. Our previous become 10, and because there is no other element left, 12 becomes the right of 10. I hope you understand how we are using a stack to finding out which is the right, and if it's smaller, we just make it to the left child and push it in the stack. We are not checking anything. So that's the simple code. Let's write the code. So this is an iterative method, and what we have to do is we have to first make the tree node, and in this question is also given that the preorder length is always greater than or equal to 10, so we don't have to check whether the input vector is empty or not. So we make the root equal to no new tree node, and what's in here is preorder of 0, because the first element is always the root node. Now we make a stack of tree node pointers, and we push back in S the root node. Okay, now what we have to do is we have to iterate over the input preorder vector from 1, because we have taken the first value, the root node, and less than equal to int preorder size, and tree node. So now we have to first store the temp value, the new tree node, which we have to insert. Of I. So this is the new node we have to insert, but where we have to insert the left or the right. So for that we have to check whether temp value, if the temp value is less than S top node value. So if it's less than the top node value, we just have to, what we can do is we just have to push S dot top dot left is equal to 10. So the top node of the stack, the left of that top node be equal to 10. Else what we have to do, if this is not true, we have to iterate over and pop out elements from the stack. So we have to keep track of the previous popped node. So for that we make a pointer pref, and while S is not empty and S dot top value is less than, if it's less than temp value, what we have to do is we have to make the previous mark at S dot top, and we have to pop out the nodes from stack. And when we reach it out, what we have to do is we have to mark. So when we come out of this loop, that's the previous value, right, is equal to 10. And after all this, we have to push temp in the stack. And return. root. That's the iterative method. So I push back. Because we are using stack, we just use push. So yeah, the tree is forming correct. Let's submit it and it's accepted. I hope you understand the logic. If you still have any doubts, please mention down in the comment box. I'll try to rectify it as soon as possible. Thank you for watching this video and I'll see you in the next one. Bye.